So normal curve, the bell curve thing. Tell me, what is the area underneath the whole thing from negative infinity to positive infinity?
The z-axis?
This is the z-axis. This is called the z-axis whenever this is the standard normal curve. The standard normal curve means that the mean is 0. This tallest part right here is the mean. And we've talked before about what the area underneath this is. So the z-axis is a collection of, the z-axis is the number line, right? So this is the z-axis. Over here you have minus infinity, and over here you have positive infinity, and this is the z-axis. Okay. Now, what is the area under this curve?
1.
Under the whole curve.
Under the whole curve.
Is 1.
All of this shaded area, you need every bit of it, all the way to infinity, coming from negative infinity.
Okay.
And that entire area is equal to 1. What is the probability of a guaranteed event?
If it happens under that area.
100%.
100%. 100% is the number 1. They're the same thing, right? Okay. Because, I mean, yeah. 0.99 is 99%. The number 1 is 100%. Okay. So right away then, there's some kind of, there's something here that we could take advantage of in terms of probability, right? Now, remember what we said when we were talking about area, hold on. What's it called? Remember what we were talking about when we said shape of a distribution. If I have a histogram has this distinct, it looks like a bar chart. It's really not. It's more than a bar chart. It's got all of the bars touching one another, because down here on this horizontal axis, this is what our classes are. It describes, all of our classes are going to live somewhere on this axis. Maybe this is your commute time to work, right? Then that's measured in time. So this is so it's continuous, right? It's continuous, just like the real number line is continuous. So that's why all of the bars would touch each other. Each one of the bars is a class. And what did we say the shape of a distribution was? It's kind of like that frequency polygon, but it's just smoothed out, because the shape of the distribution should be the smooth curve through the tops of the middle of each bar. Shape of the distribution. Now, let's make up a fictitious frequency table with just a few, maybe 5 classes. So we'll say 0 to 4 and 5 to 9 and 10.
On that one too.
Huh?
When I was trying to make one like that, I keep messing up, like, yeah. 5 and 9.
And maybe it's wait time, or maybe it's commute time or whatever. Okay. So my frequencies, I'm gonna be able to. I do my experiment, and what do I see happen? I see 6 people live really close, and then there's 10 here and 11, and then 3. I want to make a relative frequency table out of this. How do I do that? No.
You wrong.
What does these words mean? Relative frequency. This is the frequency. I saw this happen 6 times. Huh?
How many times something happened,
But it's going to be relative. Relative to what?
the size of the house.
The size of the sample. This is 30 observations. In this class, there was 6 observations. So relative to the entire sample, this is 6 out of 30.
6 out of 30.
Okay? So here you have 6 out of 30 and 10 out of 30, 11 out of 30, 3 out of 30. If I make my histogram, instead of using these as my heights, let me use these as my heights. It's this exact same histogram in terms of the bars being the same height. I could draw the histogram for this one or for this one, and they would look the same. The only thing I had to do is change the indexes, change the numbers, right? So, my first one would be, first bar would be this tall, and then the next one's that tall, and then this tall, and then I could say that this one has a height of 6, and then 10, and 11. But instead, I want to say this one has a height of 6 over 30, 10 over 30, and 11 over 30, and 3 over 30. And these classes, it's like, yeah, they say, so what is my class width here?
You class the people.
5.
5. The class width is 5, because it's the difference in consecutive lower class limits. I just want to map that over to be a width of 1. Instead of a class width of, I still want the class to still be the same as it is. I'll still have 6 observations right here, but I want to say that this bar just has a width of 1, and that this bar just has a width of 1. Like I'm transferring. So then this width of 1 would really mean 5 minutes. See what I'm saying? Okay. So 0, 1, 2, 3, 4. Okay. And this first bar has a height of 6 over 30, and 10 over 30, and 11 over 30, and 3 over 30. What is the area of this triangle? Not triangle, rectangle.
5.
The width is 1. The height is 6 over 30. So the area is, the area is 6 over 30. Because the width is 1. And this rectangle has a width of 1 and a height of 10 over 30, so its area is also 10 over 30. And this area is 11 over 30. And what did all of these numbers add up to?
Wait, which one's the ones on the right or left?
1. 30.
1.
Over 30.
1. No, you don't even
Oh,
need
yeah,
to. Look,
because they
they
all
must
add
add up to 1.
21. Oh, yeah, that's 30.
Yes.
They must add up to 1 because that is the relative frequency table. And if I make these modifications to my histogram, then the area of these bars is also 1.
And we're saying 1 as in like 100%.
Same thing. So remember, right, that there's no difference at all between 100% and the number 1. They are identical.
Yeah.
Okay. So this area is 1. And it has a shape to its distribution.
There is no curve.
So what our intention is to say that whenever a distribution is reasonably close to the normal distribution, then what we will do is just go ahead and use that perfectly smooth normal distribution, which has an area of 1, to make our calculations. What kind of calculations? Probability calculations. Looking at this histogram, we can ask questions like, what is the probability that someone from our 30-person sample has a commute time less than 10 minutes? No,
Less than 10 minutes?
less than 10 minutes.
16 over 30.
16 over 30, because it's both of these. These people are less than 10, and so are these people. And if that was 16 over 30, then it must be the case that the probability that you do not have a commute time less than 10 minutes would have to be these people over here. And since we know the whole thing is 1, then you can say what this area had to be without even looking at the numbers, because this part was 16 over 30.
And the other one's 14 over 30.
The other one must be 14 over 30, because it's got to add up to 1. All right, that is the thinking and the strategy. When we use
A relative frequency.
it's the thinking is that you can do a study, you can get a sample, you can record a bunch of information, you can make a frequency table, you can make a histogram out of that. Then you can start asking a bunch of probability questions. You could do it with your histogram, but that would just be information just about your sample. If I wanted to know, if I had my 30 people here and they're all standing in front of me and I randomly pick one of them, then the probability that randomly selected person that I picked from my group of 30, the probability that they have a commute time less than 10 minutes is 16 over 30. It must be. But what if I am able to learn that the commute times for everyone is normally distributed? Then I wouldn't be able to use my histogram. My histogram is only dealing with these 30 people. I want to be able to talk about everyone in the city of Dallas or in the country. You know, if commute times are normally distributed, then I can just go use my normal curve, and I don't even need a table or a histogram or anything to start answering probability questions. Okay? So a lot of power is had if we somehow know that a certain variable is normally distributed. Take blood pressure, for example. It's going to have
120 is the median?
yeah.
Okay.
And the standard deviation is going to be, it's really 19, but it's a lot easier to say 20, just for an example. By the way, this point right here where the curve starts to change direction, you know, it's like it's coming down sharply and then not as sharp and then it eases up a lot, right? That's called the inflection point, and that is right where the standard deviation occurs. So this number right here is 140. Then if I wanted to know the probability that someone has dangerous, you know, if I say among all Americans, blood pressure is normally distributed, then I can use this curve. Then if I ask a question that says, what is the probability someone has dangerously high blood pressure, then it would be this area right here. And I would be able to go to my calculator and calculate this area, much in the same way that in the last example, we just looked at the area of the bars of the histogram and knew that that was the probability. It's like there is a histogram here behind this, We just don't see it. The classes are infinitely small. The classes are really, really small, and the sample size is so large, it would be, all the people everywhere. And so we can have little tiny classes, but we don't even need to talk about that histogram. We're just going to use this smooth curve and understand that it can represent some underlying histogram that has rectangles whose area we can calculate explicitly just by length times width. We have a calculator in StatCrunch that's going to help us find what these areas are. Okay? That's going to be the name of the game. Operating the calculator to find the specific areas and interpreting the answer to the question. Because if so, the first 9 questions would just be a picture like this with a little shaded region, and it says find the area. Okay, and there's really no context. But there's always an underlying probability question. Whatever this area is, it is the probability that someone has very high blood pressure.
So I'm looking on the homework though.
Yeah.
And it says obviously find the area of the shaded region, Z equals 0.66.
Mm-hmm.
So I'm thinking the shaded region is 66% of 100%.
No.
No?
No.
Okay, cool.
So here's what look. So here's the thing. If it is the standard normal curve, where the mean is 0. By the way, it makes sense that this would be the tallest part because that's where the tallest bar would be. And whichever bar is the tallest, that's where the median is going to be at. And since it's symmetric, the mean and the median are about the same. Okay, so if the mean is 0 and the standard deviation is 1, then that's standard normal. And and so anything down here is going to be z-scores. What was your z-score? 0.66? Okay, so that's like this dot right here is 0.66. It's a z-score. This is the z-axis. All right, and they're wanting you to find the area to the left of it or to the right of it?
Left.
The area to the left.
So everything.
All of this area is what we are looking for. Now we need to know how to write down this area notational. Okay? And the reason to know that is because the calculator uses this notation. And it pays to know it. P for probability, capital P. The probability that Z is less than or equal to 0.66. Okay. Probability, and then in here is an event. It's the probability of an event. The event is that a randomly selected Z was less than 0.66. Okay. So it's like saying, it's like having the blood pressures over here, and then anyone over here, even if your blood pressure was this, you're still less than 0.66, so you're part of the computation. All of this area, it's a number, right? It must be a number less than 1,
Because it's not the whole thing.
because it's not the whole thing. In fact, it goes past halfway, so it must be a number bigger than 0.5. And all of this area, what is it equal to in symbols? It's equal to all of these symbols. Okay?
When it's equal, what do you mean? It's equal to all the symbols?
This collection of symbols is this area.
The Z is less
Because
than
it's
or
less than
or equal to is all of that.
Did you include the P in the parentheses? Because what is the format of this? It's the probability
All of it.
of an event.
Okay.
And And this area is a probability. It's the probability of the event that some randomly selected z was less than 0.66. It's equal to some number. Symbolically, though, this is that number, all of this. When you go to your normal calculator, that's where you will need to understand this notation. Okay? Because the error that you were making right away, Riley, was thinking that the area was 0.66.
So it's just the point on the line.
It's just the point on the line. Okay? They've given you the z-score, and it is that point. We project it a straight line up, and they want to know all the area to the left. Don't they give you a picture that matches this
Pretty much it.
picture? Okay. Now, let's look at the normal calculator.
Okay, so what that whole thing was probability is z is like less than or equal to 0.66. So that means like whatever probability, or is it like kind of whatever probability you're going to find is going to be less than or equal to 0.66?
Mm-hmm.
Or to get to 1.
No,
Or like what does it mean by the probability is? So that's what
the probability is that area
Oh, okay.
because it's
Is it like okay? The gears are turning.
Chance.
let's look.
So the probability is the entire shaded area.
It's the
And
probability. It's
whole
the
probability is less than or equal to 0.66.
not the whole probability. Just z-scores. Randomly selected z-scores. The probability, if like picture if you had a bunch of numbers in a bag, and these were numbers that were between negative infinity and positive infinity. Somebody told you all of these numbers in this bag normally distributed. Okay, so then and it's standard normal distribution. So that means the average number, the most likely number that you would pick out of the bag is 0, right? It's got the most observations. That's where the tallest bar would be. You'd be picking a number very near 0. And then now I ask you, or I say, reach in the bag and pull out a number. And you pull it out and look at it. I'm able to tell you that the probability that the number you reached in and pulled out, the probability that that number is less than 0.66, it's whatever this area is.
Oh, so it's kind of like, oh, okay. So it's kind of like you have a 1 in 5 chance
Kind of thing, yeah.
Kind of thing. Okay.
Let's see what that number really is.
It's starting to click a little more.
Is there a way you can reset mine to where my question I can start over on number 1?
You can just ask it for a new question.
Yeah, just say,
In the
Like
bottom
a similar
right.
question?
Yeah, similar question.
Oh. So that's what it is.
So they've told us. Oh, it doesn't show the magnifier on the screen. It only shows it for me. Hopefully you can read it. If not, you can read your own. Go down here to get more help. Stack rank.
So get more help.
Mine will look a little different because I'm on iOS, but it's stat. I clicked stat, calculators, and then normal.
so mean is 0, standard deviation is 1.
Yeah, and then look at that statement that's underneath it.
Oh, P.
It
X
says
less
the
than
probability.
0,
Now
yeah.
they're using an X and not a Z. Why is that? It's because they're allowing you to change the mean and standard deviation. If it was always 0 and 1, then that would just be Z. But if I change it from 0 and 1, I shouldn't use z, because z is only for the standard normal.
Are we ever gonna be doing, I'm assuming we're gonna have to change the mean and the standard.
At some point, yes. Okay? Now, here's all those symbols that we talked about. Probability that a randomly selected number comes out less than or equal to 0. And this is how it comes out by default. Look at how half of it is shaded. And look at what number is coming out in this box.
25.
Half. So when you reach into that bag and pulled out a number, there was a 50% chance that that number was negative. Okay. So all I got to do is go here and change that 0 to 0.66, and we have,
0.74537301.
okay, let's just do the first 4 digits.
We rounding the 4th digit then?
Yes.
So it'd be 7454.
So there was about a 75% chance that the number that you picked out of the bag was less than or equal to 0.66.
Okay, cool.
Okay. And you would just type in your number. Let me tell you where it goes wrong. It goes wrong when students don't know which box to type in the thing they're given. The thing you are given is a z-score. You should not be putting it in the area spot. How can you remember for sure, no doubt, which one goes where? Just look at how the calculator came up by default. By default, the calculator showed you, as soon as you opened it, it had half of the area shaded in red, and that number, 1/2, it's filled in, right? It's telling you which box gets the area, and it's telling you which box gets the z-score. This is 0, so that's where the 0 is. This area is half, and it must be coming out here.
I'm out wrong.
Okay.
And I rounded it 4 decimal places. You know, when the substitute was here, we did mine over and over, and when we rounded it, it was wrong, but when we didn't round it, it was right.
What,
Here on the homework. 'Cause I put mine in the.
what's your
class.
z-score?
It's 0.78 is the Z.
So 0.7823. That's what these first 4 numbers are. 0.7823. I'm sorry, it's small. Wish I could make it bigger for you. Oh, I can.
Oh, you put it on that side. Okay, I see. That's the one.
Look at you. What did I just say? Check it out.
Oh,
The calculator is going to load again fresh. Pay attention.
Okay.
I'm going to go to Stat, Calculators, Normal. I haven't done a thing. How much area is shaded?
50%.
Where is the 50% at?
Oh, there's the right.
Should you be typing in numbers that are not areas into this box?
No.
Okay. This is the score that's related to that 50%. And look at where it is. Scores, areas. Okay. And so the calculator itself will help you remember that. Let's make sure we're rounding correctly. When you, so it was 0.78, I think.
Oh, yes. So it'll be point.
Whatever, you know, so
3.
we will always want to follow. I don't know which question you were talking about from last week, but if the instructions say to round, we must. I mean, there's there's no ambiguity. There's no, how can I say this? Was it on the percentiles where you're having that problem?
Yeah, I think so. It was the one where you had to add them all up, and then we had to equal like 100 or something, and then we had to square root it. It was somewhere in there where it
It
went
was
over
the
rounded.
variance deviation or something like
We did it over and over, and it kept giving me like the answer that wasn't rounded.
I don't know what you're talking about.
Okay.
You know, if you're computing variances, so last week was week 3, and that wasn't even on last week.
You want to see what it was?
Yes, I do. Okay, this is, so this, however you did this, don't do it that way.
I
Look,
messed up somewhere, huh?
You
I feel like last
you
week
do
there
those-
was a stat crunch that we could have used for it.
Yes,
We're trying
that,
to figure it
there is
out.
a stat
Yeah,
crunch.
We were trying to figure it out. We were brainstorming. We put all our brains together and it didn't work. However.
All right, hold on one second. Let's just talk about that right quick, because you're going to have a quiz on that, and
I already took the midterm. It was on the midterm.
it was on the midterm.
Yeah, it was on the-
Yeah, I was messed up on
All right,
trying to have that.
I'll-
I mean, I honestly did kind of good on the midterm, Loki. I got like 98 on it.
Me too.
Really?
Me too.
Not 98%, but 98
Did
out of
you get this question right?
I had 90.
Which one was that?
These. This is the questions you're talking
That's
about.
the one I couldn't.
Oh, yeah, I got
do.
that one.
I
Yeah,
think so.
did.
I mean, honestly, I don't really know remember which one
Okay.
we got that on.
So-
I think it-
Click the button, open in StatCrunch. Stat, calculators, custom. Values are in the first one, variables or weights are in the second one. Look at how it makes a histogram, but with little skinny, what you call it? Bars. Okay. And this was the first class where you had 0 observations. This is where you had 1 observation. Look at how the heights of the bars are exactly what I was talking about at the beginning of this class, where we're having the height of the bar be a relative frequency. Okay. Then if you just imagine that the width of each of these bars is 1, and that these are their heights, then the sum of all the heights is 1. Look at how these 3 are shaded red, and this area is 0.5. This is the probability that you witnessed the event come out less than 2. Whatever this was about. Maybe it was about the X-linked chromosome or whatever. What's going to happen if I put less than or equal to 5? What's going to be the answer it's going to say?
what's it?
Huh?
I'll probably be like 100 or 0.
And what number is that?
1.
1. It's going to be the number 1. This is like an intro to what we're doing now. How do you, and the questions that they were asking you were calculate the mean and standard deviation. Well, look, there they are. It just did it for me like that. I don't do
Yeah,
that.
so now we had to do add them up, divide this, do this, square root that, freaking. Then now you got to subtract these from that, and then this, and I'm gonna
Yeah.
jump out the window.
It is harder. It's like x times p of x square root.
Do that.
Y'all were saying that, we just couldn't find it.
Okay. Well, this is it. It's the stat calculators custom.
That's not homework 3.
So homework 3,
I'm gonna do it for us.
and it's like the last 4 or 5 questions like that. And they're completely effortless. Don't feel bad because in the past classes, I will only have shown people this way, and they won't remember, and they just skip them altogether and get it completely wrong. At least you went through the.
That's their own prerogative.
Now, this mean is a very easy number to calculate. It's this one that's harder. Okay, this number is going to come back and revisit us in a discussion board in the future. This will be called something different. Here it's just called the mean of this probability table. Later on, we will call it the expected value. The expected value. Because whatever this experiment is, you can see it's normally distributed. All right? Then if then this being 2.5 says that, if I ever repeat this experiment in the future and just randomly select someone, this is the number of children I can expect to have the genetic disorder if I pick a group at random. On average, it'll have 2.5. It was just a weighted average. It was just this probability times 0, times this class, this probability times this class, and you add them up all the way down. So, and that'll be in week, I think maybe it's week 5. No, week 5 is, that's only warm up to Hell Week. It's week 6, that's hard.
Wasn't 4, 5, and 6 weeks like the really bad ones?
Well, you're in 4 now, and it's actually not that bad. It's like 4, 5, 6.
I like how this statistics class we're learning about histograms and bell
This
curves.
is crazy.
And the weeks are like a histogram and bell curve.
Yeah,
You get it?
it is really, because it's going to start off easy and then get real hard, and then it's going to get easier as you get towards the end of the course.
Kind of funny. So now I'm on the negative one.
Me too, and it was the wrong.
Hold on, let me get to homework 4.
You got a
What?
minus of 1.
I
So-
did.
Hold on. Did you get question 1?
Yes, I did.
You got question 1? Okay. Then, it's true that you can say 1 minus this area to the left, okay? Just like what we talked about earlier. However, you can also just say that you want the probability of minus 1.07, that you want the probability that z is greater than or equal to minus 1.07. You could just say that I want to talk about greater than minus 1.07. Okay? If I configure the calculator to say less than minus 1.07, it's going to be this area over here. If I configure it to say greater than, it will be this area over here. And that just makes it to have one less step that needs to be done. So, stat calculators normal. For me, it's z is minus 1.07, so I'll change my inequality to be a greater than. And look how it changes. It matches the picture that
Oh,
that they gave me. Right.
okay. I didn't change the color.
I'm still mind blown from when you just told us about last week's.
Oh yeah.
So
I just have to go do it for myself.
Yeah, it does it just like that.
That's crazy.
Yeah, I don't ever show
all we
anybody
gotta do is
to
change the little sign. Interesting.
do this. Yeah, it switches it to the other
That's
side.
the thing of remembering that when you have a test.
So now if we got
That's why I'm writing down
a
exactly
negative
how to do it
and a
stat.
positive
What you mean?
For the other one.
for the third question,
You know,
it says.
Oh,
Z,
okay, yeah. So
but
have we all got
it's
question
gonna
2?
be between now.
Hold on. Have we all got question 2?
Yes.
Okay. On number 3, it is an area that is between 2 z-scores. Now, I will tell you that you are so lucky that we have StatCrunch to do this for us, because if you had to do it the way classes had to do it when I started working here, we didn't have StatCrunch. What we would have said is that an area between 2 numbers can be computed by finding the bigger area and taking away the smaller area. Make sure you can see that. Right. Here's this big area. Here's a little smaller area. They'll overlap, right? Then just take this number, whatever this number is, and deduct this number. And what you would have is the area that's just in between this z-score and this other z-score. Get it?
Yeah. But we have StatCrunch, so.
Yeah.
Makes my life
So-
so much easier.
The notation would be it would be the probability that we saw our z-score coming out in between A and B. A and B are fixed numbers. This is the one that gets randomly selected. The probability that it comes out in between these fixed numbers is an area. And it would be, I mean, if I overlaid the two, there's this red area, I just transferred it to over here, so this probability that's down here, it is this part that's just between A and B. Okay. There's a convenient button at the top of the StatCrunch calculator, says between. And when you look at the notation at the bottom, it has the two numbers for you. Okay. In fact, look at how it came out by default. By default, just when I hit between, it put in a -1 and a 1 and gave me this area. Now this is the standard normal curve, so that means the standard deviation is 1. Can we remember back to what we said about this thing called the empirical rule? No. It would have been I don't remember when I would have said it. Maybe weeks 1 and 2. So
What you said, what, empirical or something?
empirical rule. It's the empirical rule. It says that 68% of the observations occur within one standard deviation of the mean. Within 2 standard deviations of the mean, you have 95% of the observations. And within 3 standard deviations of the mean, you have 99.7% of the observations. It's the empirical rule, and it says it's 68, 95, and 99.7. If 99.7% of the observations are going to happen within 3 standard deviations, that's nearly all of them. That corresponds exactly to your normal curve here at -3 and 3. There's hardly any area out there. In fact, you know how much area is out there. It's 0.3. Because here in the middle would be 99.7. And if I adjusted this to be -1 and +1, well, then that would be 68% of the area. And look at how my calculator came out right out of the box. Between -1 and 1, we have 68% of the area.
So then that leaves 42% on the outsides,
Yeah.
which would be, now is that 42% on each side, or is it
No,
42 total?
you tell me.
I think it's 42 total and then 21% on each side, right?
Yeah,
And then,
it would have to be.
yeah.
Because the whole thing adds up to 1. So whatever you take 1 minus this, and it would be the unshaded parts. All right, and look at how in my default picture, the edges of the window are -3 and 3. It doesn't even go past that because there's such a small amount of area that's out there past -3 and 3.
This was the thing you were saying, how it keeps on going for infinity, but it never
Infinity.
touches the actual
Yeah.
line, so it's never truly zero, right?
Never truly zero. You could potentially reach in that bag of numbers and pull out 50 trillion. It's just highly unlikely. The grand majority of the time, you're going to be picking out a number between -3 and 3. Okay. So In my problem, it was minus 0.88 and 1.26.
So if it's always gonna be a negative number, or if it's a negative number that we find, we have to have, or that we have, always have to change it to greater than. And if it's a positive number, it's less than equal to.
No, not necessarily. So in the context of questions, in the context of question 2, where was the shaded region? It was to the right. So we had to be looking greater.
Oh, but if it's to the left, it's less than,
Right,
because of what we're looking at in terms of the number line.
right.
Okay.
The less than or greater than impacts which side of the z-score we're looking at. Mhm. All right, did everybody get number 3?
No, I'm working on it.
Okay, let's get it.
All right.
What's the
Mine has negative 0.84.
negative 0.84 up to?
I don't know, my thing is tripping every time I put a number in, it goes away. It's getting smaller and smaller. Look, every time I click in there, it gets smaller and smaller. It's getting dirty, it's dirty. Come on, keep going.
You have some kind of key that's stuck on or something. Okay, that's the problem. Because the command to zoom or something, I think is Alt minus or Control minus or Control plus. Right? So you have a control key that's stuck on. Percussive maintenance.
All right, thank you.
Minus 1.11 up to
I got mine negative 0.84.
negative 0.8.
It's up to 1.29. Do I do anything with this one right here?
You tell me.
Nope, this one computer, put it over there.
Right. Because what is the number that's over here?
That's what I'm looking for, the number of shaded area.
It's the area. It's the area. Up to 1.26, was it? We got the same number?
I got 0.7010,
What was your upper number? 1.2?
1.29.
1.29. Yeah. So I just wanted to make sure that when we round a number, I just realized, I think I know why you had to not round something last week, because you probably you weren't carrying enough digits to satisfy the computer. You were rounding something too early because it really wasn't expecting anyone to do that by hand. It was expecting us to just use the StatCrunch calculator and then round that, because this StatCrunch calculator is going to give you an extremely precise answer. Look, this is 8 digits of area.
Yeah, because we were doing it by hand.
Yeah.
That's why I was.
So when we round, if I round this to 4 digits, if they say to round, I just want to make sure we know it does not mean to automatically increase this. I have to look at the 5th. Okay. All right, let's take 10 minutes, and when we come back, we will do the rest.
I think it just takes me practice to keep doing with that StatCrunch. 'Cause
Mm-hmm.
I'll forget it. Okay, 10-minute break, 'cause I'm hungry. year, I got that crunch, damn.
I should have took that test. I was like, how did I get that wrong? Doing it by hand. Oh my God.
Okay, well, by the way, I have a conflicting meeting with I have a meeting at 3 that conflicts with our time going all the way to 4, but this stuff doesn't take usually that long,
I'm
so.
already on question 8 or 7, so.
Me too.
Okay, cool. Well then, it must have been the case that you realize what they
That
were.
is the area.
This is
Yeah,
the
you just
area.
have to plug it in to find the Z-score.
Exactly.
But I had to like flip-flop it though, when I did my stat crunch.
What does that mean?
So like, where's this? Oh,
That sounds an awful lot like I typed the number into the wrong box.
it
Yeah,
is not, actually.
that's what I did.
It probably was, I just am making things up. Who knows? Calculator normal.
Oh, I think I know what you meant. You didn't
So-
have the correct inequality set.
That's what I think it was, because my Z score line, like the Z line is like all the way like where that one is. And so I put in, my number was 0.9875
Uh-huh.
in the area, but it was. I
The
had
negative
it-
of this.
Yeah, I have it less than or equal to.
So it gives you the negative of this number.
Yes.
That's because of the symmetry of the curve, right? If I say I want an area of 0.9890 to the right, then it must be giving me some negative number because I have 98% of the area to the right of something. Well, if 0 is right in the middle, and that's where 50%'s at, and you want 98%, it's got to be a negative number. But as soon as you flip the inequality, it's just going to give you the positive version of that number. Okay, Regina, on number 4, they're asking us for the z-score that corresponds to this area. They've given us the area. We need to find the z-score that does it. So I would come into my area box and specify that area. If I just hit enter, then it's given me the area to the left because of the less than or equal symbol. And that is what they wanted in this question.
Okay.
So the z-score, only rounded to 2 digits for z-scores, I would put 2.29.
Here's the one where it was giving me the funky ones. So like for me, the area was for this one, the area is 0.1635, and I have the symbol set to less than or equal to, and then I hit compute, and it's negative 0.901. But then I flip it to pop to greater than or equal to, and it just changes the area, not the actual z-score.
That's because
But the z-score is negative, but my answer is positive.
the area that it gives you here is simply 1 minus the old area. The calculator will allow you to give it an area and it will find the z-score. But if then after the fact, if I start changing this inequality, it holds this z-score. So if I change this inequality, the z-score would stay the same and the area would update. Okay? But if I first change my inequality and then say I want the area of 1635, then the number that I get for my z-score is of the same magnitude. It just doesn't have the minus symbol. Okay?
So you have to change the sign before you put all the numbers in.
The inequality.
Yeah, change the inequality before you put all the numbers in.
Yep. That's a best practice.
Mine was wrong. I'm gonna try
On which one?
on the fourth one. And
Question
now the
4?
picture didn't come out. It's doing it where it's half again. It's supposed to.
Question 4. They gave you an area. What was that area?
It was 0.9131.
Is it to the left or to the right?
It is to the left. But look, when I go on here, it gave me this, not like this. Something's wrong with
Okay.
my computer.
Here we are.
No, because you don't have anything
Okay. So I'm looking for the area, the clear area that's not shaded in. That's what I'm looking for. So I'll put that in the right.
but this one, see that number?
You're looking for an area that's to the left
Mhm.
of some z-score.
That's why I was trying to go over there, but no, it's not. It's gonna be opposite. So I have that area, right?
This box being on the left or right has nothing to do with this left or this right.
Oh.
Area,
Mhm.
z-score.
Okay.
I'm looking for a z-score. I'm looking for a z-score. So the number I want will come out in that box. See how this picture
Mhm.
matches this picture. Pictures match.
Mhm.
So I know I've got it configured right. 1.36.
Thank you.
Number 5 should be largely the same. It's just an area on the other side of some z-score. So this one is an area to the right. I'll change my inequality so that it reads as areas to the right. I have some z-score and there's an area to the right. Now I can go dictate what that area should be, 0.1660. And so I'm always wanting to inspect, is the picture I'm getting from the calculator matching the picture that they gave me in the problem? Right. You got that, number 5?
I was telling the other one, my computer been acting up. It just keeps throwing me out. Now I'm about to fix it out.
How's it doing?
I don't know. whenever I try to type an answer and it goes to, makes me go back into homework again, I have to go to the actual question. I don't know why it keeps doing it, but.
Let's figure it out.
And do I have to put the zero ahead of this every time I write in something?
No.
So I'm going to go get
Is that an area, does that picture match this picture?
No, I need to change the symbol.
You change it. Does that picture match?
No.
Okay, what needs to be fixed?
I need to put this into there. No, I didn't put something right. Let me change.
Is this area that area?
Is this area? No, doesn't look like it.
No, that's not right.
Oh, what's that?
I want you to make these pictures match.
Okay.
What should change? I want you to type in an area to make these pictures match. There we go. 0.92. All right, now we'll type it in.
That's just fidgety, isn't it?
And the next one, they have some context to the problem. It's about blood pressures. Or it's IQ scores, excuse me. So they said that IQ scores have an average of 100, standard deviation of 15. What is this area mean to us? Whatever this number is for this area, it is the probability that a randomly selected person has an IQ score less than or equal to 80. This area is the probability a randomly selected person has an IQ less than or equal to 80. Okay. So now I will go to my StatCrunch window, which, by the way, you can just leave open. You don't have to close it. You can just go back to it and modify the numbers. I give it the mean and the standard deviation. If we didn't have this feature, we would have to use a z-score that we would have to do that observed minus the mean over the standard deviation to get it. I would have to say 80 minus 100 over 15, and it would give me a z-score. And I could then take that z-score and just put it into the standard normal curve right here, because that's where z-scores go. But since I'm able to dictate what the mean and standard deviation are, I don't have to do that process. I can just come down here and type 80. Is my inequality going to be correct? I want to know about the probability of a randomly selected person having IQ.
No,
Needs to go the other way. Less than or equal to 80. Do you see how this stuff between the parentheses is an event? Okay, yeah, it's the event that the randomly selected person I picked had an IQ less than or equal to 80. And that probability is, it's about 9% chance.
Isn't IQ 80 like bad?
Well, it's on the lower side, right? Okay. It's more than one, so that's a great question. Is it bad? All you would want to know is how many standard deviations away from the mean is it?
So 20, 100.
1 and a quarter, 1 and a third.
This is the z-score, right? It is the number of standard deviations away from the mean that 80 is.
The z-score is.
The z-score is the number of standard deviations. So yeah, it's 1 1/3. 1.3. So you'd have just a minus 20 over 15, so that's minus 4/3. So they're below the mean, more than one standard deviation, but it's not 2 standard deviations. Okay, but it is on the lower side. It is on the lower side. In fact, only about 9% of people are going to have that score or lower. Okay. But 9% is still a lot.
Yeah.
Well, depending on the sample size. Right?
What is, I
Well,
mean,
sample size would be.
what does this,
Sample size.
what is this distribution though? This distribution, this study didn't come from a sample.
Oh, okay.
What happened was somebody said, let us determine if IQ is normally distributed. Then we can apply these results to the entire population of people. So this is all persons,
Oh, okay.
right? If I had done some study and then just looked at the bars of the histogram and calculated the areas of the bars, then that would be a probability that's just for my sample. This is for everybody in the distribution,
Okay.
or everybody in the population, excuse me. Everybody in the population. This is for the population, and the histogram is for the sample.
Sample size. Gotcha.
All right, did we all get that one? In the next one, it's also about IQ. It's just between,
I'm stuck on this one.
okay? So mine is, this is the probability question of what is the probability that a randomly selected person has an IQ between 80 and 110. That would be this area. I could also say that whatever this area is, that's the proportion of people whose IQ is between 80 and 110. So we have two perspectives.
So you can say for just,
Say it was 30%.
30%. So I have a 30% chance of pulling somebody out with an IQ in between 80 and 110.
Yes?
But however, I could also say that 30% of the people have an IQ between 80 and 110.
Yes.
Cool. Awesome.
So I'll go to between.
Mhm.
I'll come down here and I'll put my numbers 80 and 110. Turns out it's 65.63, or it's 65%, 0.6563.
Okay, why wasn't it doing that?
All right, that was number 7. Kiara, you got it?
7?
Okay. Okay. Number 8. Something seems different here. There used to be more. Y'all have 12 questions?
Yeah.
Okay. I guess oh, there it is. So number 8. It's still with the IQ scores, but now it's an area that they've given us. So I'll switch back to standard. I'll put in my area. And I get an IQ score. Now, this is the places where this calculator really shines, because if you have to do this in those tables, it would be, it's really troublesome to try and do it with those stupid tables. Okay? And one of the problems is that There is not an area on that table that's exactly 0.6. You would just have to approximate.
I think statistics is a lot harder without stack mesh.
It is. That's why, I mean, everybody that's doing it for a living is using some piece of statistical software. That doesn't mean that it's simple all of a sudden. It's just like, it's in the same spirit that, airline pilots use autopilot. They can fly the plane, but it's going to be, you're going to have a much better experience if the autopilot's working. So, okay, so this is about IQs. Interpret this scenario.
Basically, out of 60% of the people, you'll have 100, basically up to 60%, no wait, 103 IQ.
60% of people have
103 IQ or below.
Yeah.
That's what I was trying to say.
103.8. Alternately, you could say that a randomly selected person,
That's a 60% chance that their IQ is less than 100, greater than or less than or equal to 103.
yes. All right, do we all get that one? Number 9's the same deal. It's just an area to the right. So switch your inequality first to make it read to the right. When I say to the right, I'm talking about here's my number and the area is to the right of it. So the 0.85 though is still an area. It's just that this area being on the right side of that number means I'll have to use my greater than inequality. Greater than, I think it was 0.8. 0.85. Okay. Kiara, interpret me this. What does this mean in these probability statements, these two different probability statements?
Can you repeat the question?
I want to know, so 80, I got an area of 0.85. We got an IQ of 84.45. Put that together for me in a sentence that's correct. What is it? What does it mean?
So the probability that
I'll start you off. There's an 85% chance of
there's an 85% chance that those people have
a randomly selected person has
an IQ of 85 or higher, or 8.5.
84.45 or higher. There's an 85% chance that a randomly selected person has an IQ bigger than this. Or you could say 85% of all the people have an IQ bigger than or equal to this.
So it goes
Either way, they mean the same thing. Right? If 85% of all the people have this as their IQ, and then I go randomly select one, then I had an 85% chance of picking somebody that was belonging to that group. Okay. So that's number 9. How we doing?
I'm stuck on
I'm
Yep.
stuck too. I'm putting it.
Everybody on 10? 10 doesn't have a picture. That's how you know you're on.
Oh, no.
10? Riley, are you on 10?
Yeah, I'm butthurt at the first answer. I got it correctly, I just didn't put it in
I'm stuck on the C. C.
there.
Okay,
But
so,
see,
yeah. You just got to do it in 2 steps.
the height.
So we have that it's normally distributed. That's the main first observation. Heights are normally distributed. That means everybody, all of the women all of the women's heights follow the normal distribution, so I can use the normal curve with this as its average and this as its standard deviation. So 63.4 and 2.4. 63.4 and 2.4. Part A, or they go on to say that the requirement is that you must be between 58 and 80 inches tall. If you're too tall, you won't fit in the helicopter, and if you're too short, you can't reach the pedals. So, Part A, find the percentage of women meeting the height requirement. Did anybody already get Part A? You did, right? Okay, so what do I do?
So actually, part A.
Is that correct?
What are you going to put? What's the first thing I got to do here?
You gotta change whatever you're meaning.
My mean and deviation are already
You're-
done. Okay.
What are we looking for?
They gave us height requirements of 58 and 80
So I gotta do between.
between. I'll switch it to between, and I'll put in those height requirements because the corresponding area that I get can be interpreted as the percentage of all the women that belong to this event, the event that their height is between 58 and 80. And I've got 98.78%. It's nearly all of them. So nearly all the women are qualified height-wise. So, and they want me to enter it as a percentage. Is that where you screwed up, Riley?
Yeah.
So 98.78%. Are many women being denied the opportunity? No, because only a small percentage are not allowed to join because of their height. The percentage that are not allowed to join because of their height is 1.22%. Because when I add together 1.22% and this percent, it's 100%. It's everybody. All right. Part B.
Part B is where it gets confusing. 1% of the shortest people and
Yeah, this is where.
2% of the tallest people, then what would the height requirements be?
Regina, what were you saying?
I'm gonna do another question because it's, mine was wrong.
Did you type it in as a percentage?
Yeah.
Did you do it this way?
They got 98.78, I got 98.8.
How'd you write it?
I put 98.8 instead of 98.78.
But when you went to
You have
your,
to do the 2 decimals over it. So like,
So 1, 2, I
So-
still would've got 98.8.
so see how many is like that? So that's 9930. Inflate it 99.30. Now if it's 0, instead of 2 right next to 0, it's like a 5 or above, then it would be
you just do them one at a time.
9.3.
Caught up
So
on
you're not
question
rounding
10.
that number, you're rounding
But I know how to do
this. So it'd be
question
98.78.
And it's similar, so I don't know.
It is similar. So you have an asymmetrical region that you have to deal with.
Well, that's just, yeah. So
The
like
picture that they're wanting here, where we're gonna say, like, look, originally, only 1.22% of women were excluded. But look at what they're gonna do now. Now 3% of women are going to be excluded, right? It's the shortest 1% and the tallest 2%. This picture would have 3% of the area shaded, where 1% is the left tail and 2% is the right tail. We just need to do it in 2 stages. First, we'll make the calculator give us I'll put 1% of the area in the left tail, and I'll get a number. That number will be the short limit. And when I do 2% of area in the right tail, it will be the upper limit.
No, do we go back to standard to do that?
No?
Just go on in between?
Yeah, because I'm wanting a height, right?
Okay.
Oh, no, I know what you meant now. Yes, we have to go to standard.
Okay. So now,
I thought you were saying the standard
No, yeah,
curve.
standard for the graph.
So if I want the shortest 1%, well then this is 1%. When I hit enter, it gives me that height. There's 1% way over there in that tail. The height that does that is 57.82 inches.
And then for the, you want the tallest, we go greater than 2%. Point 0.02.
Yeah. So I'll have to change my inequality to read so that it's on the right side and then put 2%.
It's a drastic cutoff with the tallest in inches and shortest. That's pretty cool.
But can you see how this picture it's literally meaning that the tallest this is the tallest 2%. It's 2% of the area. It's on the tall side, so it's the tallest 2%. That cutoff would be 68.3 for me. So it's very helpful to have the picture in your mind, and that when the problem is like this and it's just in words, you'll need a picture somewhere to help guide you. And the clues here was that it was the shortest 1%. That means we needed a 1% area on the left, and then the tallest 2%, we needed a 2% area on the right. Regina, did you get 10?
No, I'm still working on the one before that. It keeps saying invalid input for mean. This value must be a number.
We can't be having problems. We gotta get it fixed.
I don't know what's going on. Do I have the mean 63.6?
Okay.
Right, that's a comment.
So this is on problem 10 now, right?
Yeah.
Okay.
Tiffany, 80.
Okay. 0.98745. So 98.75. Right.
Let's go with this. It's a nice word. Now, are many women being denied the opportunity to join another? Not because when I'm making it 75, so no, because only a small percent of women are not allowed. Okay. No, because it's in your own agreement. No, very small, right? No, that's not it. It'll be this one. Because only small, right? Right. Has to be at least 58 inch.
You need to read part B at the top. Because this down here is the answer to that question.
Except the shortest 1% and the tallest 2%. What are the new height requirements? To get these. What would I do then
Well, so look at how it says they want to let in people who are taller than the shortest 1%. So at some point, I'm going to need to find what height is it that gives me the shortest 1% of people. Go to the calculator. It should already be open. Don't do that.
Okay.
Find where it's already open that you didn't close it. Just move this window. Click on the Chrome thing. See the all these. Okay?
Okay.
So, not this one, we can get rid of that. This is the one we were just working on. Okay, it's already got our mean standard deviation, we're not having to retype it. Now, they want the shortest 1%. They want the shortest 1% of people.
So the shortest 1%? How do I find that out?
Okay, well, let me tell you who's in the shortest 50%. Wouldn't it make sense that right at the mean, to the left of it, you would have 50%? I mean, the mean is right in the middle, and there's 50%. What are you gonna do if it's needing 1%?
Double it?
You're gonna double it if it needs 1%.
Because we have 50 and we're trying to get to 100.
1% is definitely not
Oh, I
100%.
see, this is at 50, so I wanted like,
Tiny down there,
Yeah.
1%, okay?
so do I change it to like 0.1?
0.1 is 10%.
I mean, 0.1,
0.01 is 1%.
okay, and then compute it.
Compute. Okay, so then that height is the height for the shortest 1%. The shortest 1% of women are that height, or they are shorter than
And
that.
so the next one, I'll just do 0.2 since it's asking for 2 bricks. No?
So go ahead and hit enter. Is that the tallest 2%?
Oh, the tallest, okay. Oh, no, it's not.
It's not, we have it. Okay.
I'm gonna switch this over.
You're gonna switch that, because as soon as you switch that, it doesn't read to the left of this number, it reads to the right of that number. No. Look at how much that area is. Do you wanna let in the tallest 97% of people?
So the 2.
You wanna let in the tallest, or do you wanna exclude the tallest 2% of people?
Yeah.
Like that. There. So then those are the two heights. Just a 1 decimal place.
I'm tricky at first.
Number 11. Did you already get number 11?
I don't think so.
Kiara, did you do number 11? Did you do 12 already?
No, I'm stuck on 12. I kind of, I'm kind of good.
12 is really important for you because of the context of
Yeah, it's dealing with temperatures.
being a
Okay,
nurse.
now I'm on 11.
But what about 9? Okay.
That's the one I asked for a new question.
Yeah.
So, let me just see.
It definitely can't be 119. How could I know that?
115.
Look at how this has 90% of the area, right?
Mhm.
And what is the number that's right in the middle where it would say 50%?
Oh, you said the number that would be half this right there?
Yeah.
It would be 0.90%, like 45 or something?
You're thinking half of 90%. That's not right.
So you said what would be the number in the middle of this?
I want to know what is the number right in the middle on this horizontal axis.
Oh, 0.5.
That would be the area
Mhm.
that corresponds to the number right in the middle.
Mhm.
That number at the bottom is not 0.5. The number at the bottom, right in the center,
Mhm.
is the mean.
Oh, yeah. There you go. Okay.
Okay, so what number is right in the middle at the bottom?
100.
100. So if this picture had said 50%, then my answer would be 100. My answer would be the IQ that has 50% of the area to the right is 100. Well, you've got 119. Do you see how that can't be possible? Because if 100 is in the middle, 119 is surely not less than 100. Okay.
All right.
So in all likelihood, the problem was the wrong inequality.
I'll be easier. 100.
The mean is 100, the standard deviation is 15. Not 50. Okay. They want an area to the right,
So we'll be pointed the opposite way.
okay? And you're going to give it that area that they dictated. See how 100 is right in the middle?
Okay.
Number 11 is a funny question. We'll go on to number 12, and we'll circle back around as needed. Number 12 is about body temperature. And this is a important conceptual question for us, given the future job that you're going to have. So it says that human body temperatures normally distributed. So we can use this normal distribution and talk about all of the humans. The mean is 98.22, the standard deviation 0.63. So I'll put that in. .22 and 0.63. Okay. The first thing that they're asking me is about the reasonableness of this quantity as a cutoff for what's considered to be a fever. Are fevers low temperatures or high temperatures?
High.
High. So, if I were to shade the area on that curve to the right of 100.6, then I would know the percentage of who? I would know the percentage of normal and healthy people such that when I measure their temperature, I get 100.6 or bigger. Does that seem, now just before you do anything, if someone is normal and healthy, and I go and I measure their temperature, and I look at it and it says 100.6, should that be happening very often? No. Because they're normal and healthy. Okay. But it still could.
Yeah, if you're outside in the sun and you do like a surface temp, then yeah.
Yeah, something could happen like that.
Core temp, no, yeah. But if you have people, that's just.
So,
So we put 100.6 in the Z, or the Z part?
it's, well, 100 point, I wouldn't make any sense to go in the area box, would it? Because it's not, the only things coming out of that area box are numbers between 0 and 1. So this setup right here is saying, for an average body temperature with this standard deviation, I want to know the probability a randomly selected normal and healthy person has a temperature greater than 100.6. That's going to be slim.
Yeah, mine's like 0.00007242.
Okay? Rounded to 4 digits is 0.0001. If I round this to 4 digits, that's 0.0001. Converted then to a percentage is 0.01%. So the percentage of normal and healthy people that would be considered to have a fever is 0.01%. Is that a good thing for a hospital to be doing? Well, you know, what it's going to do is it's sufficiently high so that only sick people are being labeled as having a fever. How often would a normal and healthy person be labeled as so we associate fever with sickness. How often would a normal and healthy person be mislabeled as sick? It'd be pretty slim. You know, this is how often it's going to happen.
0.000%, basically.
100%. It'd be 1 in 10,000 people.
That'd be wild, actually. If they put 10,000 people and just like a normal healthy dude, 100%.
Yeah, so that's exactly right. Get together 10,000 normal and healthy people. On the average, one of them is going to have a temperature that's 100.6 or bigger, and there's nothing wrong with it.
It'd be kind of wild.
It would be. Okay. So does this percentage of 0.01% suggests that the cutoff is appropriate. Yes, it does, because there's such a small probability that a normal and healthy person would be considered to have a fever. Right? It'd be like having a false positive. We want to limit those false positives. We don't want the hospital swarming with people that we're freaking out about. Oh, you've got a fever, and it turns out that they really don't, because our figure that we were using, our cutoff, would have been too low. Right? So this cutoff of 100.6 is sufficiently high to keep out all of the normal and healthy people that there's really nothing wrong with them. That way, if we measure a temperature and we see 100.6 or bigger, we really have strong confidence that there's something wrong. And it's not an intuition. Oh, no, my medical book said that we're not supposed to have, this high temperature, so we think that's something wrong. No, here it's just mathematically. You cannot be having a number this big and then also be normal and healthy, but for this percentage of the time.
Yeah.
Okay. So the minimum temperature for requiring further medical tests should be some such and such temperature if we only want 5% of normal and healthy people to exceed this temperature.
All we gotta do is put 0.05 on the percent thing.
On which side?
On the right side.
On the right side, because that's where the fevers are, on the high side. So, in other words, this says normal and healthy people, 5% of them have this as their temperature or higher. So I wanted a temperature that said that only 5% of people would have this temperature or bigger, and that temperature is 99.256. Getting the 12?
Oh, I hate my computer, it's acting up again.
How's it acting?
It's like doing all of this. It's going somewhere else, I'll even have that open. Let's start all over again. It's like, the first part, right? Now it was making me put my mean and stuff all over again, so I have to do that every time.
No. You only have to do that when you close the Stack Crunch window. So just don't close it and you'll be fine. Right? In fact, let's do this. I'm going to move this and crash it into the side. Boom, now it's half. Okay. Since it's now half of the screen, what I'll do is just make the other half the Stack Crunch. And I'll always be able to see both. Just take it, crash it into the side.
Oh, that's pretty cool. Every time I mess around with something like that, it goes everywhere. Okay.
And then just don't close the Stack Crunch. You could have done the whole assignment on the same Stack Crunch window the whole time. All right. What is this called? What is this area called?
Greater than.
Greater.
So it's, gonna be 0.05, right, it's 5%.
5%.
Then just include it.
Not include anything, yeah. Click in that box. Now just type it in and then press enter.
The whole thing?
Yeah, never stay off of the trackpad. I think that's part of the problem. So we're ready to type in there. You want to type in, to round it to 2 decimal places.
So 99.25?
99.25. Enter. Enter.
Oh, enter. Okay. See, I'm new to computer.
Okay.
All right, cool.
So then, we're done with everything else, right? Yeah. Except for you, it's number 11. All right, on number 11, it has a funny joke in it. Yeah, I think so. Didn't you?
Oh, it was a trick. It was a trick.
There's a pregnant woman, and yeah.
Like, he is not the father.
It says that pregnancies are normally, just lengths of pregnancies are normally distributed. For me, the mean is 268 days with a standard deviation of 15 days. So, average pregnancy length is 268, standard deviation 15. The question that they're asking is about a woman who had a pregnancy that lasted 309 days. The pregnancy lasted 309 days, and she had given birth after her husband had visited her. So she gave birth 309 days after her husband visited her. He was working out of the country. She gave birth 309 days later. So we have to wonder, what's the probability that you would have a pregnancy that lasted 309 days? So this says that there is a 0.3% chance that you will have a pregnancy that lasts 309 days. So it sure does look like she was already pregnant. The probability that she was already pregnant when he came to visit is very high. It's 99.7% chance. It could be the case that he is the father, but the probability that that is true is small. It's not impossible, it's just improbable. So, the probability that he is the father is 0.0031.
I have the same answer and it's still saying mine is wrong. 0.0031.
Well, do you have the same mean and standard deviation that I do?
268 and 15.
Okay.
And then I ended up with the
And
zero.
How long was her pregnancy?
309 days.
That's almost a whole year. I would look at her and say, you
Cheated on me.
And it said it was wrong.
Yours is not 309 days.
Where did I see 9 at my eye? My eyes get. Okay, now. So 38. The little stuff like that, I'm messing up. Okay. That's all I wrote that last.
And I didn't even look at your actual question. I just looked at your statement.
On the right, you got the old.
What does the result suggest? The result suggests that either a very rare event occurred or the husband is not the father.
I'll guarantee you 99% of the time, so she will say, but it can happen, so it's probably yours.
Been there, done that. Hell.
But that's a misuse of the word
Been
probably.
there, done that, yes.
The correct word to have used would have been possible.
Possibly.
It's possible. It's possible, and the degree of that possibility is measured right here. It's possible, but with only this amount of probability.
So your next question would be, how possible?
I'd be like, you know
This
what?
amount.
You can statisticize this with me.
You can
show
only-
me how
you can
possible it is.
You can only use that. You can only use that word probably if this is bigger than what number?
1.
Can't be bigger than 1. It's guaranteed if it's 1.
Oh, less than 1.
This is less than 1.
What was the question again?
If I wanted, if
0.5?
0.5, if she wants to say that it's probably yours, then this would have to be 0.5 or bigger. Right? Does that make sense, Rob?
Sorry, checked out.
If I'm talking about I flip a coin, it's probably heads. Who's to say? There would have to be a bigger than 50% chance of it landing on heads for me to say it's probably heads. So if this number is coming out bigger than 0.5, then it's probably
Yes.
yours. Otherwise, it's possible.
Possibly. So if it's essentially more than 50,
Yeah.
probably less than 50, possibly.
Yes. I mean, no matter what the number is, it's possibly,
Yeah.
right? Unless it's 1, then it's just guaranteed. Or it's 0, then it's not possible. All the other numbers in between are possible, but probably refers to more than 50%.
Okay.
Yeah. I mean, if, like, I'm, let's see. Trying to think of something that always happens with more than 50%. I mean,
More than 50.
that's not grim, because the first thing I was going to think of is you'll probably make it home when you leave here.
Honestly,
Who the hell knows?
I mean, it's not true that every time we go drive back and forth to school that we're crashing 50% or more of the time, right? It's less than that.
Didn't they say statistically speaking, it's safer to ride a roller coaster? Like if you're driving to the amusement park, you're more likely to get in an accident going to the amusement park than actually being in the amusement park.
I believe it.
I believe that too, because like they shut down those rides for like the most minusculous thing.
They used to. It's been getting worse, I hear.
Yeah, 'cause I've seen it. So,
Babies who are born on or before what date or how many days into the pregnancy are considered premature? Well, I need to look up here at what they defined premature to be. They said, if the length of the pregnancy is in the lowest 3%, then that's what we'll call premature. So, I should make my curve have 3% of the area on the low side. I didn't close my stack crunch,
I didn't do that.
so that way it still has my mean and standard deviation plugged in, and I can just come over here and say 3%. And when I hit enter, it paints 3% of the area on the low side, and it's 239.7 days, so 240 days. 240-day pregnancy or shorter will be a premature